Welcome to Investing 4.0, Visionary Investing in Future Trends. My name is Martin. Today we're going to talk about artificial intelligence. Artificial intelligence is the big mega trend that is out there for some time now already, but I think it's just picking up momentum and we are seeing exponential growth in the future. That's my prediction, and it's the one that will shape all of our lives the most significantly, I think. And that's why I picked it first, and I'm gonna spend a few minutes with you guys now to talk about what actually AI is. Then we're gonna talk about history. I think it's pretty good to understand where we're coming from and how this all developed, and then I'm gonna give you a good overview about the most important terms and also capabilities, or as I call it, powers of AI. So let's jump right into it. Now, if we talk about AI, we obviously need to understand what intelligence is. So the definition of intelligence is that intelligence is the ability to acquire and apply knowledge and skills. And if we talk about artificial intelligence, that obviously means that some devices like computers can do the same, namely acquire and apply knowledge and skills. So that's what AI is all about. It's basically trying to help us humans to be more efficient or more precise, for example. Let's jump into the history part real quick. I'm going to jump through those first topics and we're going to talk about the recent developments a little bit more in detail. So the term or the field of research, artificial intelligence, was first born and used by John McCarthy in 1956. He was at the Dartmouth conference, and together with a lot of different professors, they basically founded the very foundation of what we have today, namely AI. In the first years, actually, him and his students and the professors developed basic AIs like computers or algorithms that could play checkers, let's say simpler form of chess. If you can imagine that in the 50s or 60s, the computer power was not that good. I mean, any smartphone can fly to the moon and back now. The computers that they had back then were just not that powerful. So there was a lot of foundation building, a lot of theoretical research, a lot of math and algorithms, and computers were developing, and the power of computers was. And then in the 1980s, the AI market already grew to $1 billion US. So pretty significant at that time, especially if you consider inflation. Then in the 90s, you might remember, or you might have read somewhere, that basic production was being shifted. You probably heard about the Toyota production model and just-in-time delivery and so on. So logistics was a field that actually benefited from AI and basic prediction models for getting parts from A to B or when they are needed. Probably also heard about Kanban boards and so on. So we have those systems here, and also data mining grew in the 90s significantly. Then in 2011, the first digital assistant was introduced into smartphones, and that was basically Apple's Siri, and it was introduced into the iPhone 4S. What you might not know is that the first chatbot actually was developed about 10 years after the whole field of research was born, in 1966. Feel free to Google it. The first chatbot was Eliza, and it was obviously not as capable as Siri or Alexa is today. But it's pretty impressive that in the 60s or 70s, those chatbots were actually born, or the grandmother of chatbots was. So Siri was introduced in 2011, and also Watson by the company IBM was built. And Watson was an algorithm that could play the game Jeopardy, so the TV show Jeopardy, and Watson actually won against the two champions of Jeopardy. So at that time, a pretty big deal, and AI became more important, and the general population was more aware of AI because it kind of conquered the TV screens at home. Now, that was the basic history and basic introduction. Let's get a little level deeper and understand what AI is actually capable of. And the greatest example that I found is AlphaGo. Now, AlphaGo was developed by the company called DeepMind in 2015. And AlphaGo was designed to play the Asian game Go, which is a highly, more complex form of chess. And AlphaGo was fed with actual games that were played by humans, and it learned from those games, and it learned different strategies, and actually was capable of beating the Korean world champion at that time in 4 out of 5 games. So pretty significant. And yeah, that basically explains to you how this AI worked. It learned from human games that already happened. Now, in 2017, they stepped up their game and developed AlphaGo Zero. There were different versions of Alpha in between, or AlphaGo in between, but this is one that really impressed me the most. And AlphaGo Zero was not fed with previous games, but only with the rules of the game. And then through simulations, it learned different strategies and developed strategies on its own. So it only had the rules or laws of the game and then learned from it. And I found a pretty cool animation on the website from DeepMind, and I'm going to show it to you. And this graph actually shows how AlphaGo Zero improved and learned. And AlphaGo Zero actually was capable, after some time, beating AlphaGo in 100 out of 100 games, and therefore became the best Go player in the world. So that's pretty significant. And yeah, AlphaGo and AlphaGo Zero already teach us a lot about AI, that there's two types. One where we feed a lot of data, basically historic data or example data sets. And there's different AI that just has some rules or basic information and starts simulating or starts working from there. So today we see a big improvement with chatbots. Well, you probably know chatbots from, if you wanted to contact any kind of company via Facebook, or even on the website, and you type something into the chat, then a chatbot usually replies and tries to give you the information that you need or tries to help you out. In my opinion, they are not as good yet. I'm getting pretty frustrated with those things, and then I end up calling somebody in the call center. But I think the more we use them, the more intelligent they become. We also have chatbots that are working with voices. Let's say service bots, as we could call them. So for example, Google invented a service bot that is basically talking to you like any kind of human being. So you call somebody, you would try to make an appointment to get a haircut, and the computer answers, and you won't recognize that it's not a human on the other side of the line. I'm going to put a link in the description there. There's a pretty cool video, just 1 minute long. Check it out, it's impressive. We also see it in law or law enforcement, simple prediction models, for example. So the algorithm got a lot of data where crimes happened and now is basically predicting where the next crimes would happen, and is giving the information to police cars so the police can go to different areas where it's most likely that a crime will happen in order to prevent it before it actually happened. Pretty interesting. Also, the algorithms are pretty helpful for lawyers, for example, to scan tons of different laws and different things that might be important for a case, and speeding up their work. Healthcare, I'm not going to get into detail here, but I personally think that AI for healthcare is the biggest thing that we will see in human history when it comes to healthcare. I'll talk about this specifically in the next videos when we talk about investing, because I found a few companies that I really like that are doing amazing things. Mobility, I think I don't need to talk about this one too much. Autonomous driving, Tesla, we all know this. So that's basically AI. And even, social media, all of the ads that you get, all of the videos that you probably see here or here somewhere as the next video that pops up as a recommendation is based on algorithms, on your behavior, on what you like. They want to basically tie you to the screen. That's based on algorithms. That's AI. So you can see that's just a few examples. But AI really is everywhere. Now, the next thing we want to talk about is the terms and the capabilities of AI. And I'm going to explain you the most important terms that you need to know that will, again, already show you what AI is capable of or what it can be used for. So I'm going to explain you 4 more general terms and then 4 ways of deep learning. And just to let you know, everything, also the general terms, are basically tying into machine learning. So if you need to remember something, it's called machine learning and how it works. Just as a disclaimer, I'm not an expert. I didn't study IT or something like this. So if you think that I'm misstating something or I'm missing out important information, then feel free to comment it below. Let me know. I can learn from it. Others can learn from it. That's what I want to see here. I want to build a community that wants to learn and understand different things. Now, the first term that I want to explain to you is supervised learning. And supervised learning is pretty easy to understand because we already covered it with AlphaGo. AlphaGo, as you remember, got a data set of previous games and learned from those games. And that's what supervised learning is. It's giving an algorithm or giving a software a data set, an example data set that it could draw from, that it can learn from, that it can use, for example, like using or finding different patterns and then applying it to a new set of data. The second one is unsupervised learning, and that is what AlphaGo 0 did. It didn't get a data set or example data, it just had the basic rules of the game, and then it could simulate and learn on its own. So that's autonomous learning, and it's called unsupervised learning. Then the next term, more general term, is called narrow AI. And what we have these days, any kind of form of artificial intelligence, is narrow AI. We also call it weak AI, and that's because it's very specific. So for example, for social media, for ads, for law enforcement, we give this algorithm a task or a specific task that it should solve for us. And that's why it's, again, so specific and weak, because we only use it for problem statements, specific problem statements. For example, chatbots, they are basically searching FAQs, and then you type in something, or say other way around, you type in something, they're searching for trigger words, and then they basically come up with FAQs and trying to give you the answer that you need without you having to read all of the FAQs. It's basically more more intelligent FAQs, those chatbots. But that's why it's called weak AI or specific AI, very narrow. The opposite of it is general intelligence. And if you have seen the movie AI with Will Smith, then you know what I'm talking about. That's called strong AI, and that's because it's very flexible. So general intelligence, if we ever develop it, and it's not existing yet, and it might be a good thing, because I don't want that computers actually notice that humans are destroying the planet and therefore destroy us. Well, you've seen the movie probably. That's what we mean with the term singularity. So if computers become so intelligent that they are becoming more intelligent than we are and are not needing humans anymore, and basically, for example, trying to destroy humans because we are doing something bad, then that's called singularity. But general intelligence is actually computers being super smart and more intelligent than humans. But yeah, that's it, general intelligence. And again, most forms or all forms of AI that we have today is narrow AI, very specific and weak. So those terms, supervised and unsupervised learnings, are basically forms of teaching an algorithm how to work. And this goes into machine learning. This is basically the most important term that you need to know. And also the three other terms that I'm going to explain to you guys are basically just forms of machine learning. Now, machine learning basically just describes that a machine, like a computer or any kind of device, is learning, and it can be based on data sets or it can be based on rules. And the machine is learning and improving its behavior. So it's learning from those data sets. It's, for example, finding patterns and then applying those patterns to different data sets and trying to improve this behavior by figuring out mistakes and so on and so on. So it's building experience, and it's basically very quick interaction, spitting out results, for example. Now, deep learning is something that is used, for example, for voice or image recognition. So you know that computers can actually, for example, if you go on Facebook, can tell you this might be human A and this might be human B. It's like they can detect which person it is based on the facial points that they scan. And computers can also, for example, a Google algorithm, if you search the word cat or dog, it gives you tons of pictures about cats and dogs. Now, this is all based on self-adjusting networks. Imagine that you have 100 pictures of cats and 100 pictures of dogs, and you feed those pictures to the algorithm and also specify them. So you tell the computer, this is a dog and this is a cat. And now the computer takes those sample sets that it has and is getting new pictures and trying to discover if this is actually a cat or a dog. And if it makes mistakes, you have to correct it. And with this correctional behavior, it will learn again and will become more accurate. And that's basically what deep learning is. Feeding it tons of different data sets, for example, and it's adjusting those networks that it has in the back to learn from it. The next term is reinforcement learning, and that's what we kind of saw with AlphaGo 0 already. So it is based on developing and improving strategies with the sole outcome of maximizing its performance. So AlphaGo Zero had the purpose to win the most games that it could win, to increase to the highest elo of this game. So in the end, it achieved 100 wins out of 100 games against AlphaGo, and that's what happened here. So it's continuously simulating things and trying to improve and trying to find the best solutions. And just as a little spoiler here, I think that this form of learning is going to be super amazing when we talk about healthcare, when we talk about the pharma industry. For example, finding different bacteria, molecules, and then being able to simulate them and how different, say, vitamins interact, and therefore finding new drugs without having to test them. It's like crash tests. You might know that a lot of car companies are doing actual crash tests, but before that they are simulating crash tests because they have so much data from previous crash tests that those simulations are pretty accurate. And that's what we're seeing here as well. So we're trying to build more safe vehicles, or for the pharma industry, it could mean that we will find and very quickly find drugs that might work, or vaccines that might work, or spit out different things that might improve our whole healthcare system. So this is something that I'm really looking forward to, and I'm going to talk about a few companies that are working with this in the next videos. So let's wait for it. The last term, I think, which is important to understand, is neural networks, and that is basically the closest that we are to the human brain. So it's trying to simulate the human brain, and the beauty of it is that the algorithms are connecting to different algorithms and data sets. So we are having clouds out there everywhere, storing tons of data and information, also other algorithms. And if a computer, if someone has a, say, problem statement, it could draw from those other algorithms and data sets that might have had similar problems and use this. So we are talking about really connected neural networks like we have in the human brain, like you see here or like you see here, with the AI. Again, so far we have to tell the computer or the algorithm what to do, and at one point, if we are really supported by it and if it makes active suggestions what it could help with, and we just say yes or no, that would be pretty close to general intelligence. So that's it. That's the basic foundation that I think we all need to understand when we talk about AI. And I already had a few touch points here and there of what cool visionary projects might be, what cool companies could do in the future in order to improve all of our lives. And in the next videos, as I mentioned, I'm going to cover a few companies that are working with this or are working on this AI topic or investing in this topic in order to grow and in order to learn and to bring AI forward. And I think we all can benefit from this, and we should all invest in AI, in my opinion. Actually, I am doing it, and in order to use it and to grow our wallet. So, but that's in the next videos. If you like this video, if you have a better understanding of AI, and there's tons of more information out there, I know it, but I think that's the most important things that you need to understand before you start investing into AI. And this little knowledge that we have about AI now will make us better investors and will lead to smarter decisions when it comes to our finances. So if you like the content, if you liked it, please hit the subscribe button and the like button. I would really, really appreciate that. And see you guys next time.